So obtain admittance parameters for the given network shown below. So here this is a two-port network. It has 5 resistors. So 1 ohm resistor, 2 ohm resistor and 3 ohm resistor are series elements, and 4 ohm resistor and 6 ohm resistor are shunt elements. And port voltages and port currents are, so V1 and V2 are port voltages, and I1 and I2 are port currents. So here we can divide the two port networks into three cases, three groups. So first group is, so all the elements of a two port network are resistors, and second model is so a two port network having dependent sources, and the third model is two port network having energy storing elements. So here there is only resistors. So in the two port network there are resistors only. So there are no dependent sources and there are no energy storing elements. So here for this two port network we have to find admittance parameters, or otherwise called as Y parameters. So first point is we have to write Y parameter equations. So Y parameter equations are I1 equal to Y11 V1 plus Y12 V2, I2 equal to Y21 V1 plus Y22 V2. So where Y11, Y12, Y21, Y22 are Y parameters. So now our purpose is to solve for Y parameters. Solving for Y parameters. So how can we solve Y parameters? We have to make V2 equal to 0 to get Y11 and Y21, and we have to make V1 equal to 0 to get Y12 and Y22. So here solving for Y parameters, V2 equal to 0, making V2 equal to 0. So making V2 equal to 0 to the circuit as well as to the equations. So here V2 equal to 0 means it is short circuited. It becomes short circuit. Once it is short circuited, these two elements comes in parallel. And here if you make V2 equal to 0, this equation 1 becomes I1 equal to Y11 V1 and Y11 equal to I1 by V1 mos. So similarly equation 2 becomes I2 equal to Y21 V1 and Y21 equal to I2 by V1. So here if you apply that condition V2 equal to 0 to the circuit, so circuit becomes like this, and this is these two elements now they are in parallel, and this is I2 and I1 V1 and V2 is 0. So equation 1 becomes I1 equal to Y11 V1, Y11 equal to I1 by V1 mos, and equation 2 becomes I2 equal to Y21 V1, Y21 equal to I2 by V1 mos. So here from this circuit we have to get I1 by V1 ratio and I2 by V1 ratio, I1 by V1 ratio and I2 by V1 ratio. So here these two are in parallel. So 6 and 3 in parallel, which is equal to 2 ohms. 2 ohms, and 2 and 2 connected in series, and which is 4 ohms, and 4 and 4 comes in parallel, which is 2, and 2 and 1 in series, which becomes 3 ohms. So V1 3 ohms and I1 relation is V1 equal to 3 I1. So here I3, if you take this current as I3, so I am taking one more variable I3. I3 is the current in this branch. If current in this branch equal to current in this branch, both are same. So this circuit and this circuit is one and the same. So if we replaced the 6 and 3 connected in parallel with the 2 ohms, that's all. So here I3. Now we can write I3 as a function of I1. So by using current division rule. So here I1 is the current coming to this node, that I1 is divided into this 4 ohms and this 4 ohms. So I1 is looking equal resistors with 4 ohm resistor. So this is this branch is 4 ohms and this branch is also 4 ohms. So I3 becomes I1 by 2. So I3 equal to, or otherwise you can go with current division rule, 4 ohms by, so other resistor value, other branch impedance is 4 by, so sum of this resistor, sum of 4 ohms and resistor impedance of this branch is 4 ohms. So 4 by 4 plus 4 is 8 into I1, which is equal to 1 by 2 I1. So here I3 is 1 by 2 I1. So here I3 is 1 by 2 I1. Again we have to divide. So this I3 is divided into this branch and into this branch. So I3 is divided. So we want I2. as a function of I1. So now we can get a relation between I2 and I3. So I3 is divided into this 6 ohms and 3 ohms. So current in this direction is, so I2 is flowing in this direction. Current in this direction is minus I2. So minus I2 equal to, so that's why minus I2 equal to, so other branch resistance is 6 by, so sum of these two resistors is 9. So 6 plus 3 is 9 into I3. So I am using current division rule here. So which is equal to 2 by 3 I3. So minus I2 equal to 2 by 3. So for I3 equal to, again I3 as a function of I1. So I3 equal to 1 by 2 I1. So I3 is equals to 1 by 2 I1. So substituting for I3 equal to 1 by 2 I1. So finally we get minus I2 equal to 1 by 3 I1. So I1 equal to minus 3 I2. So this is the connection between I1 and I2. So I1 and I2 relation is I1 equal to minus 3 I2. So I1 equal to minus 3 I2. So here V1 is equals to, so if you go on reducing this network, so these two are in parallel and series, so finally we get 3 ohms. So this we can replace this entire circuit with 3 ohms. So relation between V1, 3 ohms and I1 is V1 equal to 3 I1. V1 equal to 3 I1. So I1 equal to 1 by 3 V1 and Y11 equal to I1 by V1, which is equal to 1 by 3 mhos. So Y11 value is 1 by 3 mhos. And V1 equal to 3 I1. So but we know the relation between I1 and I2. I1 and I2 relation is I1 equal to minus 3 I2. So substituting minus 3 I2 for I1, we get minus 9 I2, and Y21 equal to I2 by V1, which is equals to minus 1 by 9 mhos. So in that way we got a second parameter. Y11 is first parameter 1 by 3 mhos, and Y21 is equal to minus 1 by 9 mhos. So we got two parameters by taking this condition V2 equal to 0. So similarly we get the remaining two parameters by taking V1 equal to 0. So V1 equal to 0. So if you take V1 equal to 0, so this is short circuited, I1 is there, and once V1 is 0, this 1 ohm and 4 ohms comes in parallel, and that is in series with 2 ohms, that is in parallel with 6 ohms, and that is in series with 3 ohms. So here and equation 1 becomes I1 equal to Y12 V2, Y12 equal to I1 by V2 mhos. So similarly equation 2 becomes I2 equal to Y22 V2, Y22 equal to I2 by V2 mhos. So here these two are in parallel. So 1 ohm and 4 ohms are connected in parallel. So 1 into 4 by 1 plus 4, which is 4 by 5 ohms, 4 by 5 ohms, and 2 ohms. So for these two resistors connected in parallel, I am replacing that with one resistor, 4 by 5 ohms. If we insert current I4, I4 is the current in this 2 ohm resistor. So here also I4 equal to, I4 is the current in 2 ohm resistor. So by using current division rule here, so here by using current division rule, I2 is the current coming to the node, and that I2 is divided into this branch and this branch. So I4 equal to, so we want current in this branch, so that's why we have to take the resistor of other branch, 6 ohms by, so sum of these two resistors, 6 plus 2 plus 4 by 5 is 44 by 5 into I2. So I4 equal to 30 by 44 I2. So but I4 again, this I4 is divided into this 4 ohms and 1 ohms. So here I2 is divided into this branch and this branch, and similarly I4 is divided into 4 ohms branch and 1 ohm branch. So here minus, so we want current in this direction. Current in this direction is minus I1. So minus I1 equal to 4 by, we have to take other resistor, other branch resistor, 4 by 4 plus 1 into I4 is I1. So minus I1 equal to 4 by 5 I4. So minus I1 equal to 4 by 5. So I4 is, so in terms of I4 is 30 by 44 I2. So from this I4 equal to 30 by 44 I2. So minus I1 equal to 6 by 11 I2. So V2 equal to, so this is the relation between I1 and I2. Minus I1 equal to 6 by 11 I2. So V2 equal to, so here this is, see here, if you see this, 4 by 9 in series with 2 ohms, so is 1.9 and 1.9. So here if this for this 2 ohms which is in series with 4 by 5 and that is in parallel with 6, we can replace this entire 3 resistors with one resistor whose value is 1.9 ohms, so close to 2 ohms. So 2 and 5 connected in series is 5 ohms. V2 equal to 5 I2. So V2 equal to 4.9 I2 or 5 I2. So Y22 equal to I2 by V2, which is equal to 1 by 4.9 moles. So this is the relation between V2 and I2. V2 equal to 4.9 I2. So V2 equal to 4.9. So for I2, I am writing minus 11 by 6 I1. Minus 11 by 6 I1. So Y12 equal to I1 by V2, which is equal to minus 6 by 54 minus 1 by 9. So Y12 equal to minus 1 by 9 moles. So in that way, by applying that condition V1 equal to 0, we got the remaining two parameters. So if you write all the Y parameters at one place, so Y parameters, input driving point admittance Y11 equal to 1 by 3 moles, output driving point admittance Y22 equal to 1 by 5 moles, reverse transfer admittance Y12 equal to minus 1 by 9 moles, forward transfer admittance Y21 equal to minus 1 by 9 moles. So given two-port network is reciprocal because all the elements are resistors, so that's why it is a reciprocal. So reciprocal based on the Y parameters, how can we say the given two-port network is reciprocal means if Y12 equal to Y21, then the given two-port network is reciprocal. So here if you see Y12 is minus 1 by 9 moles and Y21 is minus 1 by 9 moles. So Y12 equal to Y21. So that's why given two-port network, so as Y12 equal to Y21, given two-port network is reciprocal. Given two-port network is reciprocal. So similarly, the given two-port network is not symmetrical. So it is not a symmetrical network. By seeing the figure, we can say it is not a symmetrical. So how can you say that by using Y parameters? So by using Y parameters, if Y11 is not equal to Y22, the given two-port network is not symmetrical. So if you see the Y parameters again, Y11 is 1 by 3 moles and Y22 is 1 by 5 moles, which is not equal. So as Y11 is not equal to Y22, the given two-port network is not symmetrical. As Y11 is not equal to Y22, given two-port network is not symmetrical. So now if you draw Y parameter equivalent circuit, so this is the Y parameter equivalent circuit. V1 and I1 is the current. V1 and I1 are the port 1 voltages and current, and V2 I2 are the port 2 voltages and currents. And here it is Y11. We have to connect these two branches in parallel. So Y11 and it is a dependent current source whose value is Y12 V2, and here it is a conductance. It is a conductance. Y11 is conductance, Y22 is conductance, and here it is a voltage dependent current source Y21 V1. So here Y11 value is 1 by 3 mos and Y12 value is minus 1 by 9 mos, and Y22 value is 1 by 5 mos, and Y21 value is minus 1 by 9 mos. So finally pi equivalent circuit. So if the given two-port network is reciprocal, and if you know the Y parameters for that given two-port network, we can draw its pi equivalent circuit. The reciprocal network may be modeled by its pi equivalent circuit if you know Y parameters, YA, YB, YC. So if you know Z parameters, we can draw T equivalent circuit if it is a reciprocal network. So that is important point here. So first of all, we have to check whether the given two-port network is reciprocal or not. If the given two-port network is reciprocal, then we can draw T equivalent circuit if you know Z parameters, and we can draw pi equivalent circuit if you know Y parameters. So YA, YB, YC are the elements of pi equivalent circuit. So where YA equal to YC equal to minus Y12, which is equal to minus Y21, which is equal to 1 by 9 mos, and YA equal to Y11 plus Y12, which is equal to 1 by 3 minus 1 by 9, which is equal to 2 by 9 moles, and YB equal to Y22 plus Y21, which is equal to 1 by 5 minus 1 by 9, which is equal to 4 by 45 moles. So here finally YA equal to YC equal to 1 by 9 moles, YA equal to 2 by 9 moles, YB equal to 4 by 45 moles. So here these three circuits are one and the same. So this is the given circuit, original circuit, two-port network, and after that so performance point of view, this circuit and Y equivalent circuit. So this is Y equivalent circuit and this is pi equivalent circuit. So pi equivalent circuit. So these three circuits are one and the same. Performance point of view, these three circuits are one and the same. So this is the first problem. So first problem is so all the elements of a two-port network are resistors.